Hey, amazing sixth graders. Welcome to lesson 2 for this week. So far in this unit, we've talked about weather, we've defined climate, and we've learned about some different climate regions throughout the world. Today, we're going to move into our first lesson on global warming. And the first thing that we need to talk about is something called the greenhouse effect. So the target for today is I can explain how the greenhouse effect impacts the Earth's climate. What that means is as you're going through this lesson, I want you to think, can I explain what the greenhouse effect is? And what does it do for the Earth? Okay? All right, let's get started. And we're going to start at the moon, which may seem a little strange, but stay with me. Have you ever thought about what it would be like to live on the moon? Forget about the fact there's no air to breathe. You would also have to take into account the extreme temperatures. On the side that's facing the sun, the daytime side, it can get up to 270 degrees Fahrenheit. You would burn up. And on the side, the night side, the side facing away from the sun, it reaches temperatures of negative 280 degrees Fahrenheit. You would freeze to death. All life would freeze to death. So relatively speaking, the moon and the Earth are the same distance, or very close, from the sun. They both receive the same amount of solar radiation or energy from the sun. So why does the moon have these extreme temperature differences? Why does it almost over 400 degree difference between the day side and the night side? Why don't we see those same temperature changes here on Earth? Earth has relatively stable temperature. We have an average temperature of 59 degrees Fahrenheit, and there's not a huge difference, like a 100-degree difference, between day and night. Well, the answer to this question is a lot simpler than you might think, and it's simply because the moon does not have something that the Earth does, and that something is called the atmosphere. So the Earth's atmosphere is this invisible layer of gases that surround the Earth. It's our air that we breathe. It's around us all the time. Move your hands back and forth. You can feel yourself pushing the atmosphere, pushing the air around. The Earth's atmosphere helps keep Earth livable. The moon does not have an atmosphere. So we're going to talk about how the Earth's atmosphere protects us and helps life form here. So let's start with, what is the Earth's atmosphere made up of? What are those gases? Well, here's a pie chart that shows what the Earth's atmosphere is made up of. Air is mostly composed of nitrogen. 78% of the Earth's atmosphere, of the air around us, is nitrogen, which is surprising to some kids because they think, oh, it's all oxygen because we breathe oxygen. No, it's mostly nitrogen, about 78%. About 21% or 20.9% is oxygen, the oxygen that we breathe. And then this 1.1% that's left over, these are called trace gases. And these are going to be the ones that we're talking about today. So in these trace gases, we have argon gas. We don't really care about argon gas. It's great. Doesn't really do much. What we're going to be talking about is the other gases and the carbon dioxide. The other gases and carbon dioxide are called the greenhouse gases, and that's about 0.2% of the air around us, but that 0.2% plays a huge role. These are called greenhouse gases. So let's talk about, why do we care about greenhouse gases? What do they do? Well, greenhouse gases make the Earth livable by trapping heat in our atmosphere. So greenhouse gases work a lot like a greenhouse does. The sun's energy comes through. If you've ever been in a greenhouse, the sun's energy comes through, and then it gets trapped in here, which keeps a greenhouse pretty warm even in the middle of winter. Without greenhouse gases, if we had none, the Earth would be an icy wasteland. What that means is that the average temperature of Earth without those 0.2% of our air would be covered in ice with a temperature of negative 1 degree Fahrenheit. Greenhouse gases keep our planet livable by trapping some of the Earth's heat energy from escaping into space. And that heat trapping is known as the greenhouse effect. So let's talk about the greenhouse effect a little bit more. So sun releases radiation. It releases energy. And that energy comes down and hits the Earth's surface. And there we go. Once it hits the Earth's surface, it heats up the surface. And the surface releases that heat back up into the atmosphere. And that heat wants to escape out into space. But those greenhouse gases trap some of that heat and send it back down to Earth. So those greenhouse gases keep that heat from escaping, which keeps our planet relatively stable in temperature. Let's look at another diagram of what the greenhouse effect is. So, solar radiation. This is the energy from the sun. When it comes from the sun, there's 100% of it. If we were to put the moon here, the moon receives 100% of the Earth's solar radiation because it has no atmosphere. The Earth, on the other hand, that nitrogen and oxygen in the Earth's atmosphere, it causes some of that solar radiation or some of that energy from the sun to be reflected back out into space before it ever hits the Earth. So we get on the Earth's surface about 51% of the solar radiation that comes from the sun. The other amount is reflected by clouds, by ice on the surface, and by the atmosphere before it ever reaches the Earth. But as that solar radiation hits the Earth, it heats up the Earth, the oceans, and the land. It heats it up, and then the Earth releases that energy in the form of infrared radiation or heat. That infrared radiation tries to escape back out into space, but it gets trapped, some of it gets trapped by those greenhouse gases, that less than 0.2% of the Earth's atmosphere, traps that heat and sends it back down to the Earth, which keeps the Earth warm even when the sun is not shining on it. I hope that made sense. So basically what I'm trying to say, the greenhouse effect, it's basically like there's a giant blanket covering the Earth to keep it warm. These greenhouse gases, they act like a giant blanket. They keep that heat inside the atmosphere, which keeps the Earth's temperatures relatively stable, an average of 60 degrees Fahrenheit. Unlike the moon that goes through those extreme highs and extreme lows, we don't really see that here on Earth because of the greenhouse effect and the greenhouse gases. Okay, let's take a deeper look at what the greenhouse gases are. Greenhouse gases are those 0.2% of the air that trap the Earth's heat. They allow the sunlight to come through the atmosphere. They don't reflect the sunlight, but they prevent the heat from leaving the atmosphere. There are 6 main greenhouse gases: water vapor, carbon dioxide, methane, ozone, nitrous oxide, and chlorofluorocarbons. These are called CFCs. They do not occur naturally. These are totally human-made. So today we're talking about the natural greenhouse effect, the greenhouse effect that's been happening here on Earth for millions and millions and millions of years, not human-made global warming. So we're not going to talk about these really. So without these greenhouse gases, and here's the ones that occur very commonly in nature: carbon dioxide, water, nitrous oxide, and methane. Without those, the Earth's average temperature would be -1 degrees and covered in ice, and life as we know it would not be possible. So it's because of these greenhouse gases that trap that heat in the atmosphere that the Earth has an average temperature of 59 degrees instead of -1. So without these greenhouse gases, there would be no life on Earth. Lots of people, when you say greenhouse gases or the greenhouse effect, immediately think it's a bad thing. It is not. The greenhouse effect has been around for millions and millions and hundreds of millions of years, well before humans were here. The greenhouse effect is those gases in our atmosphere that trap the heat, which makes Earth livable. The greenhouse effect was around when dinosaurs were here. The greenhouse effect was around before dinosaurs. It is a good, inherently good thing. We will talk later in this unit about climate change, but for the most part, we need the greenhouse effect to live, and that's what I'd like you to understand. All right, enjoy the rest of your lesson.